Now for problem 3. A regular nonagon and an equilateral triangle are shown in this figure below. Each vertex of the triangle is on a midpoint of the side of the nonagon. Given that A is 6 square root of 3, what is B? All right, so on this problem, I know that this is the central angle on an equilateral triangle is 120. And when I cut that in half, for this piece, that's going to be 60. So that's 30. So I have a 30, 60, 90 triangle here. So let me go ahead and draw it. I'm going to put my 6 square root of 3 here. Here's my 30, my 60, and there's my 90. So this is the short side of my triangle. If I multiply this by square root of 3, 6 square root of 3 times square root of 3, that gives me the long side. Not that I really need that yet. So that's actually 18, because square root of 3 times square root of 3 is 3. 6 times 3 is 18 inches. So this is 18 inches right here. 18 inches. Okay, what is B? Well, B is going to be, we know that it's just twice the short leg, so it's 12 square root of 3. So that's B. All right. Now I want to find the total shaded area. So what I'm going to do is do the area of the nonagon times the area of, minus the area of the triangle. So the area of the nonagon, believe it or not, so this is 12 square root of 3. I actually know what the apothem is. So let me draw for my nonagon this central angle. So I'm going to draw this piece. I know this is 12 square root of 3. For a nonagon, if I divide 360 by 9, I'm going to get 40 degrees right there. Then I'm going to cut this triangle in half, so that's 20 degrees right there. All right? Then I'm going to have to put, here's my 12 square root of 3. I already know that, hold on a second, that's not my 12 square root of 3. My apothem was 12 square root of 3. Sorry about that. That's 12 square root of 3. So I'm looking for this side length x. And let me get a calculator. Sorry about that. So I'm going to have to set up a trig ratio. What trig ratio would be appropriate? I have adjacent and opposite. That would be tangent. So tangent of 20 equals x over 12 square root of 3. When you cross multiply, you get x equals 12 square root of 3 times tangent of 20, which sure is messy. We better go ahead and change that to a decimal. So this side right here is going to be that number. So make sure your calculator's in degrees mode. I'm in degrees, so we're good there. So we've got 12 second square root of 3. Get out of the square root. Tangent of 20. 7.564. I like 4 digits. 7.565. See, there's a 9 after that 4. So 7.565. Okay, so that's my side. So the area of my nonagon is going to be 1/2 times my apothem, which is 12 square root of 3. And my perimeter is going to be 9 of these, so it's going to be 9 times 7.565. So I'm going to go ahead and take my 7.565 times 9 times, I'm going to say this is just 6, and then times square root of 3. So we go, I'm going to take this number times 9 times 6 times square root of 3, and second square root of 3, 707.56. 5 digits, that's plenty, all right, and that would be in square inches. Okay, now I need to find the area of my triangle. Well, that one's actually a lot easier. For my equilateral triangle, I know that my apothem is, we said that it was 6 square root of 3, right? So I don't need this part. 6 square root of 3, I know this base is 18, so every side here is 36. So my perimeter is 3 times 36, which should be 108. Let me double check. 108. So my perimeter is 108 inches. The area of my equilateral triangle is 1/2 the apothem times the perimeter. It's 1/2 6 square root of 3 times 36. Oh, sorry, 108. So punching that in the calculator, first of all, I'm just going to go give you an exact answer. (324 square root of 3 square inches). And if I round this off to say 324 square root of 3 on my calculator, which is pretty straightforward, hit enter, 561.18. All right, so since I know that's 561.18, the difference between the two will be 707.56. So your area that's shaded is equal to the nonagon area minus the triangle area. I'm getting 146.8 if I put those numbers in correctly. So 146.38, and since it said to the nearest square inch, there's my answer, and we are done.